Hello, I wanted to share this video of the latest pico RGB2HDMI converter, which is a converter from RGB signals, analog RGB signals, to HDMI using a Raspberry Pi pico, shows that, and of course a analog to digital converter. So as you can see here, it is connected to the computer, a retro computer, which is a beautiful Amiga A1200. So what we do have on screen is a test screen from the Amiga test kit, and if we press the buttons on the device, you'll see that it shows a menu system. So you can go to diagnostics and see that right now the system is in 340 by 240, 16 bits of color density, no errors, and synchronization and the type of desynchronization. So as an example, you can choose a composite sync, or you can use a horizontal and vertical sync. So what we are going to be doing now is we are going to go back and go to the display. So display has many functionalities. One is to manage 4 different configurations. Right now, if we choose other configurations are going to be looking green. That is because this is a Commodore Amiga 8200 with a sync on green output, which generates an offset over the green signal. So what we have done is to include in the 4th configuration a different offset for the color. So in that way the colors are balanced. And let's continue. So we have alignment that you can switch. So as an example, I move here and I move here, and it moves. You can also go vertical, and automatic is not currently connected. And we have also gain and offset, so we can change the gain. If we increase, you will see that at some point the brightness it will change. I think it is going to be easier if I just change the display mode. So what I'm going to be doing is changing the resolution. So now it's in 320 by 240 with 16 bits of color density. Let's change it to 640 by 240, 8 bits. So in just one firmware we have the modes for displays in both of them. So let's go to diagnostics. It's 640 by 240 and 8 bit of color density. Let's go back. If we go to the display, we can go to the gain and offset, and we can change the value. As you can see, the brightness is starting to change. There you go. I like it like this. Also the offset, but we are not going to be touching that because it's configured for sync on green. So what else we have here? We have scan lines. Now, if you like scan lines, there you go. And what we have also is a configuration of the palette. Basically, you can change the graphical user interface. Let's just go here and change from green to blue the focus. Now we have to subtract the red. There you go. I like that color. Let's go back. Now it has this configuration. If we want to persist this, we can save and reboot. The system will reboot, and now if I just use it, you will have that configuration. And that's pretty much it. So 640 by 240, 320 by 240, different color densities, just one firmware, and the possibility to diagnose, to change the display, and also you can interact through a USB. You have to enable it, and of course it triggers some glitches on the UI that is being investigated, but basically you can command the system from the computer through USB. And that's pretty much it. Thanks.